So we are going to start working on geometric mean today. We're going to spend a couple days on this. Just got done talking about kind of similar triangles and proving triangles similar. And one of the things you can do with similar triangles, as you're going to see here in a little bit, is to kind of help us find missing sides. The first thing we're going to talk about is we're going to talk about what we call the geometric mean. Essentially what the geometric mean is, it's just a special type of average where we multiply numbers together and then take the square root of two numbers. So you can see our formulas that we're going to use for the geometric mean. There are two formulas that can be used. Kind of the quick formula, x is equal to the square root of AB. And then the alternate formulas, a over x is equal to x over b, which if you just cross multiply like we've been doing gives you x squared is equal to ab, which you take the square root of it, you have x is equal to the square root of ab, which is what we've been looking at as far as cross multiplying when we were working with ratios and proportions earlier in this unit. So we're just going to do some quick problems. Directions say leave your answers as decimals. We're not going to worry about simplifying the square root today. When we do these, this is going to be our A value, this is going to be our B value. We're going to use the quick formula, and it's the easiest one to do. So x is going to equal the square root of 4 times 4. Where 4 came from, I don't know. Let's try 5 again. 5 times 45. Grab my calculators out, do 5 times 45. You get 225, so you get the square root of 225. Punch that in your calculator if you need to do that. The square root of 225 is 15. So the geometric mean for 5 and 45 is 15. Number 2. A is 7, B is 11, so x is equal to the square root of 7 times 11. Handwriting this morning is great. 7 times 11 is 77, so it's the square root of 77. We're just going to punch that into our calculators. The square root of 77. I think it's 8.775, so we're going to go 8.78 is our approximation. And the last one, the geometric mean for 8 and 16. So x is going to be equal to the square root of 8 times 16. 8 times 16 is 128. So we've got the square root of 128. Square root of 128 is approximately 11.31. And I ask if you round these to your decimal to the nearest hundredth. It'd be great. So that's the geometric mean. And we use the geometric mean when we're talking about finding missing sides of similar right triangles. And that's what we're going to really work on today, is we're going to look at finding some sides of missing right triangles. Now before we do this, I want to kind of point out a couple of different things in our drawing. I've got triangle ABC sitting down here. This is triangle ABC. We can take and draw in what's called an altitude. This line right here, this line CD, this is called an altitude. An altitude to the hypotenuse divides the right triangle into two triangles that are similar to each other. So an altitude essentially goes from a vertex perpendicular to the opposite side. When we do that to the hypotenuse of a right triangle, we actually have triangles that are created that are going to be similar to each other. So if you notice in the drawing right now, we really have 3 triangles going on. We have triangle ABC, which we're going to call the whole from now on. That's going to be the whole triangle. We have a small triangle, ADC, going on. And we also have kind of this larger triangle, which is triangle DCB. So we got these three triangles going on. The whole, the small one, and the large one. And they're all right triangles. And actually all these right triangles are going to be similar to each other because of angle similarity. And because they're similar to each other, we can go ahead and write a similarity statement. Since all three triangles are similar by angle, therefore all the sides are proportional. So we can set up proportions in here to solve the different sides. And in fact, with what we have going on here, we can say that triangle, we'll say triangle CAB, which again is just ABC, CAB, that triangle there is similar to triangle DAC, our small one, which then is also similar to triangle DCB, which is this triangle right here. So if we could keep those straight in our head, I could give you missing sides. I could say that maybe this is 8, maybe this is not 8, but let's say this is 8, this is 10, and we want to find this value. And because we have a bunch of similar triangles going on here, we can set up proportions to find lengths of missing sides. Well, that's not always the easiest thing to do. So what we're going to do is we're going to take these three triangles and we're going to kind of break them down. We're going to label these different triangles. I find this kind of one of the easier ways to do this. I will say it's complicated. I had to work on this one a little bit to kind of get myself kind of straightened out on how to do this. Let's kind of work through it and see if we can do the best we can to kind of try and make this sense to you. So I know all three of these triangles are similar, and I talked about when I was outlining. At first, we kind of have this whole triangle. So because we have this whole triangle and this is going in kind of this direction, I'm just going to go ahead and label this triangle ACB. And we're going to call this the whole. And it's important that we label that as being the whole. The other thing I'm going to do is I'm going to go ahead and put tick marks in. I'm going to put a tick mark in A, and I'm going to put a double tick mark in B. And that's just going to kind of help us identify it. So if I go over to my whole triangle over here, I'm going to go ahead and give this one tick mark, and I'm going to give this one 2 tick marks. Okay, so we can kind of see the ratios that I could set up with our whole triangle, and that's our whole triangle. The next one we're going to talk about is we're going to talk about the small triangle, and we're going to label it small. You could either label it small, or you could label it, I don't know, with a triangle. You could label it whatever you want. But this, our small triangle, is this triangle that's sitting right here. Now, there are a couple things that I'm noticing as I'm trying it, because I need to label this triangle over here according to what this one looks like. So we want to be able to label this small triangle. So I'm just going to identify it. I'm just going to put a little S right here to represent small, kind of in the middle. But if I outline this, you'll notice that my right angle is now D. So I'm going to label this one right here D. And then I also notice that my A value has the 1 tick mark. Well, I don't have really 1 tick mark sitting over there, and I'm going to keep these consistent. So I'm going to put my tick mark right there. So that means that this is going to be A, and this down here is going to be C. Well, now you'll notice that C doesn't have any tick marks in it. And I kind of do this a little bit purposely. I'm going to keep the tick marks in the kind of the same spot. So my 1 tick marks are there, and my 2 tick marks are going to be here and here. But because they are similar to each other, because we've stated our similarity property here, though I didn't prove it to you, they are similar to each other. Because they are similar to each other, then that means the angles have to be congruent to each other. Two angles are congruent. The third one's going to be congruent as well. So I could actually put 2 tick marks there. I don't like to do it right away, because if I do it right away, it just kind of messes my labeling up. So I'm not going to do that. And I'm going to show you another way to do this as we get into the problems. So now we've got our third one. So the third one we're going to call the large one. Oops, sorry about that. Didn't mean for that to show up. But we kind of got this large triangle. So I'm going to put this L here. This is kind of my large triangle right here. And again, I want to kind of label it over here so I can match it up. And again, as I draw it, I notice I've got my right angle there, and my right angle is angle D. So I'm going to go ahead and put a D right there. And then I also notice that I have 2 tick marks. Now I'm always keeping my 2 tick marks down on the bottom down here. And my 2 tick marks for this one are at B. So that means I'm going to label this B. Then I can go ahead and put my 1 tick mark up here, but now this is C. So now these 3 triangles are going to be similar to each other. And we've got our similarity statement. So this is just a way to kind of set it up. So if we want to find missing sides, we could find missing sides. So earlier I said, well, if I make this 8 and I make this 10, how can we go ahead and find, nice, that's what happens when you have your finger on there. What if I want to find that one? And that's really our whole goal, is to be able to use this setup to help us find there. And if we know they're similar to each other, we can set up different proportions for these different triangles that are kind of set up in this manner. So let's look at an example. I don't want to fill that one up anymore. So let's look at an example of this. Oh, something's going on goofy with my drawing here. Give me just a second. I don't know what happened here, but whatever. It happened. Okay. So here's our drawing. Now you'll notice we don't have any A's, B's, C's, or D's listed. So if we want to label them how we had it, we could label this C, A, B, and D. But what I'm going to show you is it really doesn't matter, because we're going to kind of do this kind of the same every single time. So first thing I'm going to do is I'm going to go ahead and I'm going to put tick marks. I'm going to put 1 tick mark in A, and I'm going to put 2 tick marks in B. So that means over here on my 3 drawings, I'm going to put 1 tick mark here, and I'm going to put 2 tick marks here. So we've got our tick marks taken care of. So the first one we're always going to do is we're always going to do the whole. Okay, and now I'm just going to label the sides. I'm not going to put the A's, B's, and C's. I'm just going to go ahead and label the sides, and I'm going to see what we have. So when I look at my drawing here, my drawing looks just like this. So if I look at my right angle, you'll notice that across from the right angle, I have this side. So if I go across from my right angle, I know the length of this side. The length of this side is going to be 81 plus 144. And if I take 81 plus 144, that tells me that the measure of this angle, this side, is 225. And I don't know any more of them. That's the only one that I know. Next, I'm going to look at my small one. We're going to call this the small one. I know they're all the same size on our drawing, but we're going to call it the small one. And again, I'm kind of noticing here is my right angle. I don't know the length of the side opposite it. It's unknown. I don't know it. I'm not going to put anything there because there's nothing there in my original problem. You'll also notice that opposite my 1 tick, I have an X. So I'm going to go opposite of my 1 tick, and I'm going to put the X value because that's opposite the 1 tick. Now, I've got one other side that I need to look at, and that's the side opposite the 2 ticks. And obviously, I don't have any 2 ticks other than this one. There's no 2 ticks, but we're not dealing with this triangle right now. We're dealing with this small triangle. So that means that this must be 2 ticks. Now we've got our similar triangle kind of set up, and the opposite of our 2 ticks is 81. So I'm going to go ahead and label this as 81. So now I've taken care of my small triangle. Now I need to take care of this large triangle. And again, I'm not going to label the sides. I'm just going to call this the large triangle. And I'm going to put an L there. So again, I'm looking at this large triangle, and I'm going to start with opposite the 90. Opposite the 90, I don't know it. It doesn't tell me it. I can't figure it out. Opposite the 2. Opposite the 2 is the X. So opposite my 2 over here, this is going to be X. Now I have the opposite the 1. I don't have a 1, so I can go ahead and put a 1 there. Opposite the 1 is 144. So this is going to be 144. So now I have all of my stuff found. Now I just want to find X. And we're going to find X by setting up proportions. And because we're going to set this up by finding proportions, I need 2 sides. Well, if I look at my whole one, the only thing I know is the hypotenuse of the whole one. So because I don't know everything, I only know one thing, I'm not going to use this one. This one becomes irrelevant to me. I'm going to kind of ignore it because I don't need it. My other 2, notice, I know their corresponding sides. So I can write the ratio of the corresponding sides. To do that, it doesn't matter which side I pick. I'm going to start with the small one. I'm going to put the length of the small side, one of the small sides of the triangle, over the length of its corresponding side. So 81 corresponds with X. So that's going to be 81 over X. That's going to equal the other length of the small side that I know, which is X, over the large side that corresponds, the large one that corresponds with it, which is 144. So I'm going to go ahead and make this 144. Now you notice we can cross multiply. Cross multiply, I take X times X, that's X squared. That's going to equal 81 times 144. Well, notice what this is. This is just the geometric mean that we talked about over here. Kind of those alternate formulas for the geometric mean. And that's kind of why this stuff kind of works. So there's a multiplication there. So I'm going to go ahead and take 81 times 144. And that gives me X squared is equal to 11,664. Now you get rid of an exponent, the power of 2, by taking the square root of that. So we're going to go ahead and take the square root of 11664, and that's going to make X equal 108. So the length of our missing side there is 108. All becomes about setting up these triangles and doing the best you can with setting up these triangles. Let's look at another example. Okay, it's going to be held off in kind of the same direction, but now the things that we know are a little bit different. And again, the concepts in geometry don't change. The concept and how we set this up is going to be the same. You'll notice I put the tick marks in there for you this time into your guided notes. Concepts don't change. The difficulty of the math in this one does change a little bit, but the concepts themselves don't change. So we're going to do the same thing here. I'm not going to label the side, not going to name the triangle itself, but again, we're going to look at the whole. So we're going to label this first one. Oops, I'm going to put that a little bit lower. Let's put it down here. Call this the whole. So I'm going to look and see what I have. So I know the side opposite. I know the side opposite the hypotenuse is this whole thing. Well, how do I represent this whole thing? Well, if this was 10 and this is 225, I would say it's 10 plus 225. So it'd be 235, but it's not, it's X. So we can still put this as X plus 225. But notice in this triangle, that's the only thing we know in this triangle. We don't know the length of this side. We don't know the length of that side. So we're not even going to use that for this triangle. Okay, so next we're going to go to the small. Okay, I forgot to put my tick marks in here. Notice the tick marks over there. That tick mark has 2 this time, so I'm just going to put 2 there just to follow your guided notes. It doesn't matter where you put the tick marks, as long as you're consistent. If I put 2 on the top, put 2 on the top, on the side, whatever. So now we're going to look at our small one. So I'm going to label this S just with a small. And again, I notice opposite the 90, I can't put anything. There's nothing there. Opposite the 2 is 120. So that makes this side 120. Now, the only other side that we have in this triangle is X. So that has to go right there. And again, I could put a 1 there if we needed to, but I just kind of look at it as it's the only side that doesn't have anything. And of course, I put it on the wrong one. So let's put it on, instead of the whole, let's put it on the small one. Let's put 120 there, opposite the 2. And let's put our X there on the small instead of on the whole one. Sorry about that. Now we're going to do the large. The large triangle is right here. I'll change colors and label things in blue. Opposite the 90, I don't know, so I'm not going to label anything. The only true one I have is 1. So opposite the 1 is 120, so there's my 1. So opposite of that is 120. The only other side that I have is opposite that one, so that's obviously I could put a 2 there if I wanted to. So this is going to be 225. So we notice the ones that have 2, that's these ones. We set up the proportions. We're going to start with X. We're going to start with this. The corresponding side on the other one is 120. That's going to equal, we have to do the small. If we start with the small triangle on the numerator, we have to stay with the small. So that means we have to stay with the large. So that's 120 from this 120 over 225. Cross multiply this time, we get X times 225. That's 225X. Is going to equal 120 times 120. 120 times 120. So we get 225x is equal to 14,400. Divide by 225. We get x is equal to 64. And that's our solution for this one. All right, let's look at the next one. Oh, orientation's a little bit different now. So the orientation, I mean, kind of the same pieces still work. And we've got them drawn in their orientation. So figure out what we're going to do here. So I'm just going to put, they've got 1 and 2. So I'm going to put 1 and 2. It's in the guided notes. So we're just going to do it like that. So we're going to start out with the large one. Here's our large one right here. I guess I'll just label this large. There's my large one. So across from my 90. So across from my 90 is this whole thing right here. So 36 plus 64 is probably 100. So that's 100. So across from there has to be 100. I don't know any of the other sides. So since I don't know any of the other sides, I know that's the one I'm not going to use. We'll call this the small one. I'll put a little S there. My 90 degree, I'm going to go ahead and draw that in there. If I draw my 90, if I go this way, there's nothing there. Okay, so across from the 90, there's nothing there. Across from the 2, Across from the 2 is the x, so I'm going to go ahead and put the x there. That makes this the 1. Across from the 1 is 36, so across from the 1 is 36. We'll call this, I guess this was the whole. That's what we called that, isn't it? Sorry. And then this is the large. So that's this one right here. Across from the 90, there's nothing written there, so I don't need to write anything there. Across from the 1 is the x, so that's going to be my x. Across from the other side then, that's this distance right here, so that distance is going to be 64. So these are my 2 triangles with 2 things in them. Start with the small, doesn't matter, I'm going to do small, so I'm going to go x over its corresponding side for the large, which is 64. That's going to equal, since I started with the small, I need to stay with the small. That's 36 over its corresponding side, which is x. Cross multiply, x times x is x squared. 64 times 36. 64 times 36 is 2,304. Take the square root of both sides. Take the square root of that, and we get x is equal to 48. There's our solution. The next one. Okay, so we've got our whole triangle sitting here, a little large and a little small. So I'm going to go ahead and look at my guided notes, follow the guided notes. Again, we talked about it doesn't matter. The guided notes are sitting like that, so we're going to go like that. So we look at the whole again. So here's our whole one. And as we can see, we don't know those 2 sides. So this probably isn't going to be the one that we use, but we're just going to get used to writing it. So across from the 90, this is going to be my whole. Across from the 90 is this whole thing, which is 16 plus x. Now we're going to go to the small one. I don't know which one I use, small. What doesn't matter. We'll call this the small. So the small one is right here. Here's my right angle. The side opposite the right angle, I don't know. So that's the side opposite the right angle. I'm not going to put anything there. The side opposite the 2 is 12. So this makes this the side opposite the 1, which would end up being right there, which is our x value. Now we go to the large. The large triangle, just to get myself situated, is this one right here. I know the side opposite the 1 is 12. So the side opposite the 1 is going to be 12. But 90, we don't know. Then that makes that the side opposite the 2. The side opposite the 2 is 16. Start with the small, 12, over its corresponding side on the large, which is 16. It's got to equal small. The only other side we know is x, over the large, which is 12. Cross multiply, that's 16x. 12 times 12 is 144. Divided by 16, and we get, divide by 16, and x is equal to 9. There's our solution. All right, there's 2 more, a couple more examples I think we're going to do. That might, a couple more examples. I guess there's 4 more examples. So things are changing up a little bit now. We don't know that altitude on these next ones, and they're going to orientate each other a little bit different. You'll notice we orientated them in the guided notes, how they're oriented kind of there, but we keep them all the same. So let's look and see what we got. So there's our whole, there's our small, there's our large. So we're going to start with the whole. Oops, probably right in the pin. So this is our whole. So my whole opposite the whole is x plus 25. So it's that whole thing. So it's x plus 25. Now, I've got a 1 there in my guided notes. So I'm going to put a 1 there, and I'm going to put a 2 there. The side opposite the 1 is 65. The side opposite the 2, we don't know. Okay, so there is the whole. Now we're going to do the small. We'll call this one the small one and this one the large ones. There's my 90. Now I know the side opposite the 90. The side opposite the 90 is 65. The side opposite the 2, I don't know, so I can't put anything in the side opposite the 2, but then that makes this the 1. The opposite of that is 25. There's the 1. The opposite of that is 25. Large. This is a large one. The side opposite the 90, we don't know. So I can't put anything there. The side opposite the 1, we don't know. But we know the side then, which would be the 2, that's going to be x. But notice in our large, we only know one thing. So since we only know one thing, that's not the one we're going to use. And if you notice with the whole and the small, we've got what we needed. So it doesn't matter. We're going to start with the whole. We'll go x plus 25. Again, I'm going whole over small. Corresponding side is 65. The whole, the only other side I know is 65. The small is 25. So that's going to give me 25 times x plus 25 equals 65 times 65. Now we need to solve this equation. So distribute 25x plus 25 times 25 is 625 equals 65 times 65, which is 4,225. We are going to subtract 625 from both sides. That gives us 25x is equal to 3,600. Divide by 25. We get x is equal to 144. And we're done. Let's go this direction. All right, I'm looking at the guided notes. That has a 1 and that has a 2. A right angle there. We'll call this the whole. This is the small, and not the large. We'll put an L there and put an L there. So the whole, opposite the 90 of the whole, it tells us that whole thing is x. So I'm going to put an x there. I'm going to go ahead and erase that. The only other one, if I know the opposite of the 1. The opposite of the 1 is 60, so there's the 1. So that's going to be 60. So I know two things on that one. The small. The small, I know the opposite of the 90. I know the opposite of the 90 is 60. I don't know the opposite of the 2, so I can't put anything opposite of the 2, but I can then make that a 1, and then that's 36. Now, at this point, I'm noticing I've got my 2. Okay, if I wanted to do the large, I could do the large. And if we named the large, we could kind of do it quick. We don't know the hypotenuse, so we don't know the side opposite the 90. And we don't know the side opposite the 2, so we don't know two things. So I'm not even going to use the large. I'm not even going to put it in there. Set it up. X from my whole over 60 from my small equals 60 from my whole over, that's a 60. Let's just do this, write it a little nicer, over 36 from my small. Cross multiply. For some reason, when I do that, it erases. I'm going to write it over here so I have room. 36x equals 60 times 60. So 36x equals 60 times 60 is 3600. Divide by 36, divide by 36. X is equal to 100. There's our distance for that one. All right, next one. Go ahead and draw a little bit of a line in here so we don't get this confused. All right, there's my drawing. I'm going to go ahead and, again, I'm just noticing, I'm just doing what is in the guided notes. So, and again, it doesn't matter as long as they're consistent. We'll call this the whole, the small, and the large. So the whole is right here. So opposite the 90 is x plus 144. It's x plus 144. I don't know anything else. So I know that one's none I'm not going to use. The small. I don't know the side opposite the 90, so I'm not going to put anything there. I know the side opposite the 2 is 108. And then the side opposite, which would be the 1, as I need to put that there, is x. There's my small, there's my large. In the large, I don't know the side opposite the 90. The side opposite the 1 is 108. That makes this the 2, and that makes that 144. So small over corresponding large equals small over corresponding large. 144x equals 108 times 108. 108 times 108. We get 144x equals 11,664. Divide both sides by 144. X is equal to 81. And the last one. And again, if you want to pause the video, I don't know if I said it earlier or not, but before I do the problem, if you want to pause the video, go through it yourself, and then start the video up and see how you did. All right, so we're good. Looking at my guided notes, I've got a 2 there and a 1 there. We'll call this the whole, the large, and the small. That's my small, that's my large. If I look at the whole thing, I'm not even going to bother doing it because I don't know that and that. But just for purposes, that right there, remember that right there is y plus 225. I'm not going to use it, but go to the small. Here's our small. The side opposite the 2 is 120. There's my 2. Oops, yep, there's my 2. So that's 120. The side opposite the 1 is y. So the side opposite the 1 is y. And again, the side opposite the 90 is nothing, so I'm just not going to do it. Oops, I made this one the small. Sorry, this one's the small. This one's going to be the large. I don't know why I did that originally, but whatever, I did. In our large one, which is right here, the side opposite the 1 I know for sure is 120. My right angle is nothing. The side opposite the 2, because I could just put a 2 there, the side opposite that is 225. So we've got our setup. So we go the small over its corresponding side of the large equals the small over the corresponding side of the large. Cross multiply, 225y equals 120 times 120, which is just 120 squared. I hadn't wrote it like that yet. So 120 squared is 14,400. Okay, I should write it as 14,400 instead. Divide by 225, divide by 225. You get x is equal to 64. And there it is. So 2 parts to it today. The geometric mean. I'm going to rewind here just a little bit to remind you what geometric mean is. Remember, geometric mean is kind of a different way to calculate average, a specific average, I guess. A couple formulas for that. So we found that first, and then we went in and talked about similarity and right triangles. Hope this helped. There are different ways to do this. I got a second video on this that does this a little bit of a different way. If you're looking at trying to find an alternate way, I've got a second video on this posted as well. I'll put a link to it here at the end if you would like to find an alternate way to find geometric mean.